So let's look at this question here. If f of x is equal to x squared, then what we want to do is sketch the function f of x plus 3. Now first of all we'll look at the function f of x equals x squared. So we're just wanting a rough sketch, it doesn't have to be anything perfect. So we're going to have our x axis here, we'll have our y axis here. So when x is equal to 0, x squared is equal to 0. When x is equal to 1, x squared is equal to 1. X is 2, the squared term will be 4, and then 3 will be 9. And the same in the negative direction. So this f of x equals x squared will look something like this here. So it goes through the origin, and it goes round like this. Okay, so it's a curve like this. But now what we want to do is find f of x plus 3. Now we've seen whenever we looked at manipulating functions, whenever we add a value on, it's equivalent to shifting the function to the left. So that f of x equals x squared, it will look the same, but it's just going to be shifted 3 places to the left. So it will go 1, 2, 3. So now it looks the same as this, but it's going to cross the axis at the point minus 3, 0. So now we've got a function that looks something like this. So the next part of it says, now sketch the function f of x plus 3 minus 2. Well, we know that whenever we take 2 away, it's equivalent to taking the whole function and shifting it down. So we're going to be left with a function that is similar to the previous one, but it's going to be shifted down by 2. So we'll call that x, we'll call that y. Then it's going to be along 3 up 0, but then it's going to be shifted down by 2, so we can take that point down to 2. So the turning point here now is going to be at this point here. So the final function is going to look something like this. So it doesn't need to be exact, it's just a rough estimation of what it looks like. So we could actually rewrite the final function. We started off with x squared, so the final function f of x plus 3 minus 2 would be the function x plus 3 all squared minus 2. So that's this function here. So we started here, we shift it to the left with the x plus 3, and we shift it down with the minus 2 to get this function. And the turning point here for this is going to be at a point along minus 3 and down minus 2. Now people sometimes ask me and they get confused by the fact that if we have f of x plus 3, why doesn't it shift it to the right? That would seem kind of logical, wouldn't it? You'd have plus value and it'd shift the function to the right, and minus would shift it to the left. So let's have a look and we'll see why that isn't the case. I'll rub this bit out here just now, give us a little bit of space. So let's say we had a function, just simple function y is equal to x. So we'd have our x here, we'd have our y, and we'd have our function y is equal to x. Now if we were to then do the function f of x plus 1, then look and see what happens to each individual point. So let's say with the point 0, 0. Then the point 0, so x would now be 0, but the y value would be f of x plus 1. Well, f of x plus 1, well, it's 0 plus 1 is 1, so we come along 1, we go up 1, and we hit that axis. So it means that at the point 0, it'll have a value of 1. So at 0, it would have a value of 1. So that's a point up here now. So let's try another point. Let's say x is equal to 1. So we're looking for the y value when x is equal to 1. So when x is equal to 1, the y values are going to be 1 plus 1, which is 2, so it's the f of 2. So we come along to 2, and whenever we got to a value of 2. So it means that the f of 1 is equal to a value of 2. So that's this point up here. Now if I were to join these two lines together, these 2 points together, it would create a line. So here's the line here. But what we've done here now is we've taken this function and we've shifted it to the left. So whenever we have a x plus 1, it's going to shift to the left, and x minus 1 would shift to the right. So manipulating functions and being able to move them about is a very important thing to be able to do, and it's something that tends to be looked over. You tend to learn this and it's a very short lesson and you really forget about it, and it isn't until you go on and do further mathematics that you start coming across this, and you start looking at it and thinking, well, when did I learn this? I don't ever remember learning it. So it's something to take note of, and it's something that is actually very, very useful the further you go along in your mathematics. So thank you for listening. I'll get you in the next video. Goodbye.